All right, so welcome again to Instructional Routines for Developing Critical Thinking and Problem Solving. We're joined with our fabulous presenter, Cynthia Bell, today to talk about this very important topic for our students. I'm joined by my colleague, Danielle Callahan, behind the scenes, and I'm Lauren Osowski, a senior manager here at ProLiteracy. Next slide. So just a little bit of housekeeping. You should have your Zoom controls either on the top or bottom of your screen. They seem to move around depending on the device that you're on. You can use the chat during the webinar to introduce yourself, share links and resources with the group, or ask questions of the group. We will also use the chat to share links with you, so you can keep that open if you want to follow along. Also use the Q&A to ask questions of the presenter, content questions that you want Cynthia to address at some point during the webinar. You can put those in the Q&A. It's a lot easier for us to track those when they're in the Q&A as opposed to the chat. And we'll get to all of the questions during our webinar. Next slide. We are recording today. And after the webinar, you'll receive a follow-up email within a few days with all of this information. You'll receive a link to the recording, a copy of the slides, a summary sheet of the webinar, a transcript of the chat and Q&A, a certificate of attendance if you're joining us here live today. You will also get information about our scholarship and individual membership that are additional benefits of this Teacher Training Plus project. A separate email will go out with links to register for the coaching sessions. You can see the dates of those coaching sessions. So if you want to make a note of those, we'd love to have you join us at one of those coaching sessions to go a little more in depth on this topic with Cynthia. Next. So what are those small group coaching sessions? About 2 to 4 weeks after the webinar, we like to give participants an opportunity to meet in a small group with Cynthia to go a little bit more in depth. They are limited to 12 participants. They're meetings, not webinars, so you get to turn your camera on if you want to and really talk and dive deep with Cynthia about these topics. They're very informal, and it's an opportunity to ask questions and interact with others in the field who may be facing some of the same challenges that you are. It's a great opportunity to network and collaborate and really think about how what you're learning today in the webinar can apply to your own classroom or tutoring situation. Next. There's some information here about some additional resources for participants as a part of this Teacher Training Plus project with the webinars and coaching sessions. We are also offering a scholarship and an individual membership for all participants who are interested. So when you get this slideshow, there'll be the links to those pieces of information. Sorry, something just got in the way of my slides here. And you'll be able to access those links. I believe Danielle has also put them in the chat here. So the scholarship, you can apply for up to $1,000 of New Readers Press classroom materials for your program or class. The scholarships are available now, but there are a limited number, so definitely apply right away if you are interested. The membership is available to anyone who is not already a ProLiteracy member. Remember that if your organization is a member, you are also a member. But if you're not, you can try out this individual membership to get access to all sorts of great ProLiteracy benefits, which include our tutor training, which is also very, very helpful in addition to this project. Next. Okay, so now I'm going to pass things over to our phenomenal presenter, Cynthia Bell. We're thrilled to have her as part of this project, and we'll let you read her bio later, and you can jump right in. Thank you, Cynthia.
Hi, thank you, Lauren and Danielle. So good afternoon to everyone here that's I'm in the Eastern time zone, so it is actually afternoon for me. But if you're further west, good morning to you as well. And so we're going to just dive right in. I'm going to start with what our objectives are. So we have three objectives here for this particular session, as you can see. To articulate their understanding of instructional routines and their purpose. We talked about instructional routines a little bit in the first webinar that we did in 2023. So we're going to just still continue to have that conversation about instructional routines. We're going to deconstruct and analyze some concepts, particularly around critical thinking and problem solving, because that's what this webinar is about today. And develop a foundational understanding of and reflect on two instructional routines. So I am going to introduce two instructional routines that will help foster and develop critical thinking and problem solving. And then I also have one more objective for you as far as to think about for future participation in our coaching sessions, that you'll be able to articulate how to use either of the instructional routines in your practice by the end of a coaching session. So that's something to keep in mind, that we're going to go deeper if you attend the coaching sessions, as to how you can actually try this thing in your classroom. Today is more so kind of like introducing it to you, getting you to think about it, and then over the next week or so, maybe start thinking about how you might try to implement it or use it with your tutoring sessions or in your instructional practice. So those are objectives for today. And we're going to just start off a little bit with a little bit of reflection too, because as you can see, that's one of my goals today, to really get us to think about our practice. But first, I would like for you to take a moment and think about your math experiences in the past, how you learned. What attitudes, beliefs, and values were reflected? So take a moment to think about that, and then you can respond if you'd like to in the chat box, or you can just think about it yourself, and have that in your head. But I want to give us a moment to all like center ourselves. Think back to how you learned math at any point. And what attitudes, beliefs, and values do you believe were reflected in the way that you were taught math, right? Like, what did you think your teachers' beliefs and attitudes about how you learn math? What did you get out of that? What did you tell? What could you tell from how they taught? Going to give you another moment. If this wasn't a webinar, this would be one of those turn and talk to a partner kind of thing and share that experience. Follow a series of steps, examples on the chalkboard, right? That's what it was. That's kind of how a lot of us were taught. And so really the deeper question here I want you to think about is like, so what beliefs and values did you get out of that, right? Like when you were being taught that rote memorization, what beliefs and values were reflected from that? I went to a session at the National Council of Teachers of Mathematics in which they asked us to think about this too. And we all kind of said the same things, right? But then it was like, well, what did that really mean? Right? Like, what did that mean to me? What was my math teacher communicating with me? And I had different experiences with different math teachers. So I just wanted us to take a second and think about what that meant when we were teaching. I mean, when we were being taught. You're either good at math or you aren't. Do what you need to do to pass, right? That typically was that message, right? It was like, just get the answers, pass the test, and get out. If you don't get it now, you will always be lost. Okay. Show your work. Oh, the dread to show your work. All right. Thank you for giving everybody a chance to reflect there for a second. So let's talk about instructional routines. And you're gonna see over the course why I asked that question. We're gonna get back to that, to this thought, as far as what we're reflecting in the way that we teach. But first, let's just make sure that we're all saying the same thing about what instructional routines are. So they are tasks that are enacted in your classroom that structure the relationship between the teacher and the student, or the instructor and the learner, around content in ways that consistently maintain high expectations. So there's some keywords there, right? Like consistency there, expectations. The teacher knows when you're doing an instructional routine, the teacher knows what the students expect of the teacher, and the students know what the teacher expects of them, right? That's the whole beauty in doing instructional routines. And yes, you can do them in other content areas, but they kind of really got their grassroots in math, because there are a lot of really good instructional routines out there for teaching math. And as you can see here, there are specific and repeatable designs for learning that support both that teacher and student, again, in your classroom. And they give opportunities. They give opportunities. So this is why I'm a big fan of instructional routines. Um, and I'm constantly advocating for them. I do, you do, we do is not necessarily an instructional routine. That's more so a structure for the class, because it doesn't necessarily indicate the expectations that are there. I do see we have a raised hand, so if you need to, I think you can do the Q&A or drop it in the chat, or maybe that was an accidental thing. So we're gonna do a warm-up, all right? We're gonna jump right into a warm-up, get those brains going since you all have already reflected. And this warm-up is actually going to model one of our instructional routines. But first, we're gonna do a warm-up. So we're going to go over Mentimeter. That is one of my favorite interactive tools. So I'm going to drop the link in the chat box, but I would actually recommend that you access it using another device. That way you're not switching between browser windows and tabs and all those other things. So I would recommend scanning the QR code with your mobile device and accessing the Mentimeter. Nevertheless, I will drop the link in the chat box for you. I am going to go over to the Mentimeter just to make sure that's started. Don't worry, the QR code will still be there so that you can see it. And I'm sure some people are already over there because they're, the quick people here. So exit, escape, go to our Mentimeter, present so that you can see it. Okay, and here's the QR code again if you want to scan it. So here's our warm up for today, right? The statement multiplying a number by 10 will give a product greater than 10. And then I gave you the notation 10A is greater than 10, can be classified as. So I'm asking you to classify that statement. Is it always true? Is it sometimes true? Or is it never true? I'll give you a moment to think about it without me talking. Again, you can access the Mentimeter 3 different ways. You can click on the link in the chat box. You can also, as you see at the top of the screen, it says you can go to menti.com and put in that code, or you can scan the QR code. Wow, this is like a runaway train. We've got 17 people saying sometimes true. We've got 1 person saying always true. And so far, we have no one saying never true. There are about 19 responses so far, and we have approximately 50 participants. So I'm going to wait maybe another 20 seconds to see if anybody else wants to get their vote in. Multiplying a number by 10 will give a product greater than 10. All right, we've hit at least 50% of you have voted. You can continue to vote, but I am going to move on. I love someone dropped in the chat box, usually. Usually. This is why I love this particular routine. And those of you might have already even guessed what the routine is, but I wanted to just have that as our warm-up so you can be primed and ready to go with our critical thinking. So let's do some definition setting here. I need my speaker notes back because once I exited, my speaker notes went away. So let's give the definition of critical thinking. Now, there is not really, it was really hard for me to find like one set definition on critical thinking. There's been a lot of research around it, and there's research around like critical thinking in different areas. So it was really hard to pin down like one agreed upon Webster's dictionary definition of what critical thinking is. But I did find one that seemed to really sum up all of the ideas around critical thinking. So critical thinking is basically, here's our definition: careful, goal-directed thinking. I really liked this one because it kind of, as I said, summarized most of like what all of the ideas out there was. Careful, goal-directed thinking. I love these two adjectives, careful and goal-directed. There are some features of critical thinking. It is done for the purpose of making up one's mind about what to believe or do. And the person engaging in the thinking is trying to fulfill some kind of standard of adequacy or accuracy appropriate to the thinking. So when we're talking about critical thinking today, this is the idea, this is the concept of which we're approaching. And needless to say, this is a skill, right? This is a skill. This goes beyond just mathematics. Yes, we would like to teach critical thinking. Hopefully we are teaching critical thinking in our math classroom, but all of us know critical thinking is an everyday adulting employable skill, which is why it's careful goal-directed thinking for the purpose of making up one's mind about what to do or believe. And there are some characteristics of it. So let's talk about problem solving. And if you're wondering, well, what is she going to tell us what the right answer is for the question? She just asks that question and I'm on the edge of my seat to know. I'm not going to tell you the right answer right now because I love the fact that you're thinking about it. We're talking about critical thinking right now. So here's the definition for problem solving. Problem solving is the ability to identify problems, brainstorm and analyze answers, and implement the best solutions. I'm going to read that one more time. It is the ability to identify problems, brainstorm and analyze answers, and implement the best solutions. Problem solving is not just getting the answer to a word problem. But that tends to be like the go-to thinking for a lot of us math instructors or math practitioners, or even sometimes learners. When we say we're going to engage in problem solving, the first thing that pops in our head is, oh, we're going to do word problems. I don't know about you, but my life is not full of word problems, and I problem solve all the time. And my life is not full of word problems. Problem solving is the ability to identify problems, brainstorm and analyze answers to problems, and implement the best solutions. And there are some features of problem solving: evaluating, analyzing, synthesizing, and applying information to attain a solution. Evaluating, analyzing, synthesizing, and applying information to attain a solution. So if you think about it, you probably teach problem solving a lot more often than you think that you do, in a lot of different areas in your ABE, HSC, literacy programs. So this is what we're going to be talking about. We're going to be introducing 2 instructional routines that will help develop these 2 things, because these are very critical skills. They're critical skills for not just math, but for workforce, for life. Someone's ability to identify a problem and come up with the best solution for that problem, that is a life skill. Someone's ability to have careful, goal-directed thinking about problems, that is a life skill. I agree with you, Kate, as well, right? Reflection is critical. That's why we started off with reflection, right? And we're going to reflect throughout the day. Okay, so got to make sure we're all saying the same thing. We're all on the same page about what critical thinking and problem solving are, so that we can have the instructional routines. So now I want us to think about this particular statement. The best instructors and teachers show learners where to look, but they don't tell them what to see. I love this statement. This has now like become my new educational philosophy for this year. My previous educational philosophy was answers are the byproduct of doing mathematics. They are not the goal. Because again, the whole problem solving thing, a lot of people feel like they do math just to get answers. Answers come when I do math, but it's not the reason why I do math. So that used to be my educational philosophy, but this year I'm adopting this one. Okay, so we're going to reflect again for a second. Think about your practice. Okay, so before we said think about how you learn, but now I want you to think about your practice. Now that we've gone a little bit in depth, a little bit deeper into the need for critical thinking skills, developing them, the need for problem skills and developing them. And you might have been sitting there going, yeah, I agree that these things are important in everyday life, da, 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 da. But now I want you to think about your practice and the way that you teach math or tutor math. What attitudes and beliefs and values is it actually reflecting? The same way you thought about how your teachers taught you and you thought, well, this is what I think they're trying to tell me. How do you think your instruction looks? You can type that in the chat box if you want to, but you don't have to. This one was more so a rhetorical thing. I really wanted to give you a chance to think about that because I think this is really important. And I ask myself this a lot when I'm teaching too. What am I conveying when I'm teaching this lesson? What are my students believing that I'm saying about their abilities? Sometimes when I'm coaching teachers one-on-one and we start talking about different ways to elevate higher expectations, one of the most given responses that I hear is my students can't. My students can't do that. My students can't do this. My students can't because of X, Y, and Z. And I pose that question back. Are your students feeling that, right, from the way you teach? If your approach is that I know they can't do this, your students more than likely are sensing that belief in your instruction. So I want to think about what values and attitudes and beliefs are our instruction reflecting. Does your practice reflect believing that your students can build critical thinking and problem solving skills? And what would that look like? Does going step by step by step by step every single time through a problem reflect that you believe your students can build critical thinking and problem solving skills? These are all things to think about. That's all I really want to do is give us a chance to think about this. So now let's move on though, because you're like, Cynthia, what are these instructional routines? Well, we've actually already done one. So the first instructional routine, this one is for critical thinking. In fact, this was my favorite instructional routine for like a good 7 years while I was teaching. This was my go-to instructional routine. I love this. It's called classifying statements. So here's what it does. It provides learners with the opportunity to think critically about mathematical ideas or concepts. It can be used as both formative and summative assessment. I'll talk about more about that in a second. Encourages reasoning and sense making while critiquing the reasoning of others. So you're hitting a number of the standards for mathematical practices if you engage in this instructional routine. And it's a great way to address mathematical misconceptions. This one here is my favorite, one of the reasons why I would do it. So, well, what's classifying statements? We actually already did it, our warm up. I gave us a statement that said, if I multiply a number by 10, the product that I get is greater than 10. And you had to classify if it was sometimes, always, or never true. So here's exactly the procedure for how it works with classifying statements. First, you give a statement, one or more statements, and you can do it individually or you can put them in small groups, 2 to 3 people. And then you ask them to classify each one of those statements. Is it sometimes true? Is it always true? Is it never true? And then the next step is they have to justify why they've classified it the way that they had, which is what we're about to now do. So we're going to go back to the Mentimeter. I will drop the link one more time because before you voted, you classified it. You said it's sometimes, always, or never true. But now I'm going to ask you to justify it. So justify your truth. So a lot of people just went ahead and put their answers. Here, you actually have to justify it. And the way you justify it is you have to give at least 2 proofs. You have to give a counterexample and an example if you said sometimes true, or you have to give 2 examples that show that it is true, or some kind of working explanation. You have to justify. You can't just say it's sometimes true. Remember, problem solving says brainstorm answers for solutions. So you've classified it. Now tell me why you've classified it. You have to give 2 proofs. And about 25 people said sometimes true, which means you're going to have to give me one that shows when it is true and one shows that it's not true. Otherwise, you haven't justified that it's sometimes true. So I'm going to give you a second to respond and do that. Hopefully, I don't have it set at that you can only give one answer because some of you had already put in there sometimes true, and this was the place to justify it. Let's see what we've got. I agree, well, Rob. Don't even get me started on fractions. I itch just a little bit every time I hear a student say keep, change, flip. And I'm like, do you know why you're keeping, why you're changing, and why you're flipping? And then the answer is almost always because my teacher said so. Is that reflecting their ability to critically think and problem solve? But now, if their teacher gave them an opportunity to think about why keep, change, flip, now that's different, right? Hence that reflecting. What is the way I'm teaching? What is it telling my students that I think about their beliefs? I mean, about their ability to critically think and problem solve. Let's see. Half of 10 is 5, which is less than 10. 2 times 10 is 20, which is greater than 10. I feel like the test writers don't know why we keep change flip either. That's why I said I'm not going to open up that can of worms, Rob. Multiplying by 10 times a positive number will be greater than 10. I always look for a student who says something about zero. Remember, I said sometimes I use classifying statements as a means of formative assessment. This is it. Like if I were about to go into my unit, I might even just do this one statement or maybe even 2 or 3 statements because it's going to tell me a lot about what my students already know or what misconceptions they have, right? Giving them a chance to think about this and explain. I can hear, oh, okay, which ones are thinking just in the positive numbers or integers, which ones are going to bring up the zero. I see here someone brought up the negative number, right? Like that tells me a lot about that student who already thought about the negative number. Um, and also, I said I use it to address misconceptions. One of my favorite statements that I will give when I want to really poke out a misconception, I will say just this statement on the board. A negative and a negative number is a positive. Because I hear that all the time. If I had a dime for every time I heard a negative and negative is a positive, I would have at least $1,000. Right. So I'm going to put that out there and I'm going to see how many always truths I get. A negative and a negative is not a positive because if a negative and a negative was a positive, I'd quit my job and shop all day and become a billionaire because I would just keep going into debt because my debt would magically turn into a positive thing. A negative and a negative is not a positive, right? A negative times or divided by a negative is a positive, right? But I'm going to put that statement to see where we are. That's one of my favorite statements to put out there for formative assessment. Let me see where my students are. This is why I love classifying statements. Sometimes, always, or never true. Somebody said, do you have ESL examples for critical thinking? No, unfortunately, because this one is for math. But this instructional routine, I'm sure most of these instructional routines you can adopt. But that's not my area of expertise. Maybe Danielle or Lauren might drop something for you in the chat box there or recommend the ESL TTP for you. Okay, somebody said I was just talking to my son about this last night. Okay, right? Hence understanding. Okay, so we actually just went through the first instructional routine, but I'm going to finish giving you how it works just in case you're really interested in wanting to run this or try it before a coaching session. So remember we said first give them the routine, the statements. Sorry, I pressed the wrong button. Give them the statements. I meant to make the screen bigger. Give them the statements. There are lots of ways that you can modify this. Sometimes, as I said, I would use it as a summative assessment, meaning like at the end of my unit. It was the end of my unit. I wouldn't give a quiz or a test. My summative assessment would be like 10 statements, and I put them together with a partner, and that was my whole class period. You and your partner classify all of these statements and make sure you justify it. So it doesn't matter if it's 1 statement, 5 statements, 10 statements. That's up to you what your learning goals are for that day. Doesn't matter necessarily if you want to have them do it independently or collectively in small groups, but I would not advise more than 2 or 3 students. They classify the statement, then you have to give 2 justifications, 2 proofs. And then the final thing is once you're done with that, here's my favorite part of it, especially if you're going to do it as a summative assessment, do a gallery walk, right? So now that's why we said critical thinking and thinking about other people's thinking. Me and my partner classified these statements, but now me and my partner go look at what other people classified them as. And that is the beauty there because me and my partner might have said this is always true, but then we go around the room and see 4 other people say this is sometimes true, and we see their justifications for it. And so now we take in that information, critical thinking, and we adjust our thinking, or maybe no, we really firmly believe ours. And now we're going to push back and say, okay, I'm a skeptic. You defend your answer. All of that is critical thinking. So there are lots of ways that you could do this instructional routine. I'm going to pause there to see if anybody has any questions about the particular routine as far as the steps or the procedures for how to run it. All right, so I have an example. I actually did this activity, this instructional routine with a group of teachers. And I did it remotely. So in case you teach remotely, I want you to see it's possible to do this too. I did this on Jamboard and I gave them the statements. I put the statements on the side. And this is one group. This is actual work from a group of teachers. As you can see, they're group two. And here's how they classified their statements. I'm going to give you a second to look at the statements to see if you agree. Do you agree with all of the classifications? If you don't, type in the chat box which one you don't agree with. You can even go by color if you want. You can say, I don't agree with the green one or the red one, or you can type the whole statement. But take a second look. Do you agree with every classification that you see here? While you all are doing that, someone gave me a question, and it's a good question. What if the student is so lost with the logic that they cannot think of any examples and remain confused by an explanation? I would give them some push and support there a little bit, because a lot of times what we perceive as them being lost is not actually the case. And this is why I said, again, what our beliefs are that we're conveying to our students, because they can think for themselves. They can think of things, but a lot of times it's like, I don't want to say what you don't want me to say, teacher. Like, I get that a lot. What do you want me to say? Right. So they might have actual reasonings or justifications behind it, but they think it's not like mathy enough, or they think it's not the answer that you're looking for. This is the beauty of instructional routines, right? We said it sets that expectation. So the first few times you're running it, you have to give those examples and let them know that they have the ability to give their examples in any way. Right. That's why I said it could be justifying with mathematical examples or counter examples, or even giving like anecdotal proof, right? Like maybe they want to talk about it. Maybe they want to draw an example. So there are lots of ways that you could help that student who may be, quote, lost in their logic. Let's see. Yes, I'm aware Jamboard is sunsetting, and I've already been looking at other alternatives to use it. But for now, I'm going to continue to use Jamboard as long as I can. I believe it's supposed to be sunsetting in the summertime. Let's see. So we've got uh, green, purple, not blue. We've got lots of different answers that people are justifying or thinking and critiquing. Because remember, I said this is the last step of instructional routine, thinking about other people's thinking. I do believe I picked this one on purpose because I knew all of the answers weren't right. Um, uh, Multiplying a number by 10 will give a product greater than 10. They labeled as always true. We literally just did that one, right? We've already justified why it's sometimes true, because if you multiply it by 0, or if you multiply it by a negative number, that number is not greater than 10. And there's this math book called, not math book, it's an article that was written that was brilliant, called Rules That Expire. I like to address those misconceptions from rules that expire by doing classifying statements. This is one of them. In elementary school, we're taught that when you multiply numbers, they get bigger. That is a rule that expires. That is not always true, but unfortunately, sometimes the people that come to our classrooms hold on to those things. That's why I said I like this instructional routine, because it's a good way to get at those misconceptions, and let's break it down. Let's deconstruct it. Let's see if that does make sense all the time. Because every time I multiply numbers, they don't always get bigger. Depends on the numbers I'm multiplying. What happens when you multiply by a fraction? If I multiply by a fraction, does the number get bigger? So I believe we know that that was not always true. Thank you all for participating in that. I wanted you to see, like, this is how the routine could look, and model it for you for a brief moment. Now, if you're sitting there wondering, okay, I might be invested in this, but where would I come up with these statements? I don't have the time to come up with those statements. I actually have some links to a blog post about this particular instructional routine, and another link that has like statements that were already made for teachers to use if you wanted to try them. They're going to go out on the follow-up sheet that Danielle is going to be sending for people who participate in this webinar. So you will actually get both of those links to help you out. Maybe if you're like, I don't know where to start, I wouldn't be able to think of these things. Plus you've got 5 here. These are all in my lower number sense units. As you can see, these are all like number sense statements here to really get at like where we are with the number sense. Okay. I am going to stop sharing my screen for 1 second because I'm seeing the next slide that's ahead and the answer is actually there. So I need to go fix that. That way you guys don't see the answer. So I'm going to stop sharing for 1 second and make sure that that is not the case, because when I was practicing it, I showed the answer. So there we go. That's now we're good. The answer's not showing. Okay, so on speaker notes, I'm going to share my screen again. There we go. Okay, so here's our second instructional routine, multiple solution problems. I really like this one for problem solving. Again, we were talking about what problem solving is. It's identifying a problem, being able to brainstorm. I love that word, brainstorm answers and analyze answers and then look for best solutions. So let's think about life. In life, most things are more than just the answer is 7. In fact, a lot of things in life, the answer is more than one answer. And if we want to talk about the test for a second, the GED does have questions that have more than one right answer. So instructional routines, by implementing tasks that have multiple solutions as the answer, is a really good routine to use. So we're going to do one. I'm going to show you a problem, and I'm actually going to layer in another instructional routine. Back in September, at that instructional routine webinar that I did, one of the instructional routines that I introduced was the slow reveal graph, but I said that you could actually do it with the word problem as well. This might be a good one to use with the ESOL, as in you slow reveal the problem. Because when you give the whole problem, what we know just with research, they're actually like, those things where you can track the eyes, people's eyes go straight to the numbers. They don't think about the context that's in the problem. They go straight to the numbers and they start trying to do things with those numbers and not necessarily engage in critical thinking about the context that's there and problem solving as far as brainstorming and analyzing answers. So I'm going to slowly reveal part by part by part of this problem to you. Keep in mind, this is a multiple solution problem. There is more than one correct answer. Okay, so I'm going to start to drag it slowly. And if you would like to process like collectively, feel free to do that, right? If you want to like think about it and drop in the chat box what you're thinking about, or if you want to take a note for yourself, feel free to do that, right? That's why we're doing it piece by piece, so that you can take some time. It forces the learner to take some time to actually take in all of the information piece by piece. So if you want to drop what you're thinking in the chat box, please go ahead and do that. I'm going to have to come out of, going to have to come out of that mode and then make this bigger so that I can actually drag it down. There we go. Okay. First piece here. Let's see if I can make that bigger. There we go. Here's the first piece. At a rural cabin, water must be drawn from a well using buckets. So take that in. Even if you make a mental image in your head, like that's problem solving. There are different ways to take in text. I am actually a mental person. I take it in and I'm like, ooh, I'm at a cabin. There's a well, there's buckets. What do you notice? What do you wonder? Are you wondering how many buckets? Are you wondering where that cabin is? Are you wondering about the water? Next piece of information. There are only a 4-gallon bucket and a 9-gallon bucket available in the cabin. Kate said, I'm thinking there's a hole in the bucket. Okay. Now you've got more information. There are only a 4-gallon bucket and a 9-gallon bucket available in the cabin. Take a moment, notice, wonder. What are you going to do with that information? Next piece. Okay, now I am going to give you a heads up. This is the question, but there is more information. So don't fall into that trap of I saw numbers, I saw question, do things. There is more information. Okay, but still taking this information. Notice, wonder. In one trip to the well, what whole number amounts of water in gallons could you bring back to the cabin in the buckets? There's a lot of information that was in this part. All my literacy people, all my SOL people, access this, right? Whole number, amounts, one trip. I always get that question. Somebody's always like, am I the one carrying it? Well, it does say you. They're like, well, so does that matter? Do I have to have the ability to do it? And in this case, these are all really good questions. All right, here's the last piece of information, and then I'm going to give you a chance to actually try to solve it. Note, this is the best piece of the information here. Note, there are no other markings on the pails, on the buckets. You may not estimate an exact whole number amounts only. So now I'm going to give you about 2 to 3 minutes to try and think about your answers. Don't immediately start typing things in the chat box because you might inform someone who's thinking about it. Give everybody at least a minute. And you've already gotten a heads up because I told you it's a multiple solution problem. But when I introduce this normally, I don't say it's a multiple solution problem because I want to know who's going to do some close reading of the text. Yes, no problem. Good question, Mary. Nope, we only have this information. There are only these 2 buckets. And that's a good question, Mary. You're like, if there are additional buckets at the well, if there were, that wouldn't help you because it says you only get 1 trip. So you have to leave the cabin with the buckets to go to the well, I think, if I'm understanding this correctly. But now you're making me think about it a whole lot of different way. And this slosh factor, I love that you all are thinking about all of these variables. Hence, critical thinking, right? Problem solving. What did we say one of the verbs in problem solving is? Brainstorming, analyzing information, synthesizing. Okay, so now if you want, just for time's sake, we got about 3 more minutes because I want to give us time to reflect. If you want to start trying to put some of your answers in the chat box, you can. Here's the only downside to this being a webinar because the beauty of these kind of things are in that interactive interaction, like me bouncing off of you and you saying something that makes me go, huh, right? But for now, let's see where we can get with that. How deep is the well? And is there a crank? 9 gallons would be heavy to draw up without one. Good question. 0, 4, 9, 13, 4, 8, 12, 4, 5, 8, 9, 13. Also 8. 4, 5, 9, 13. What about 10? Kim says, yes, 10. I would like someone to critique her thinking. I'm not saying she's right. I'm not saying she's wrong, but I would like someone to critique her thinking. This is what we would do, right? If our goal is about critical thinking and problem solving, these kinds of questions, these kinds of conversations, this is what these instructional routines will pull. Okay, so now we've got 0 through 13. I would say you're going to have to justify 7, 11, 12, 5, right? Like these are all the kinds of questions that you want to have happen if you're trying to really promote critical thinking and problem solving. Okay, but I do believe that it helped when I said it was multiple solution problems. I would say if you want to take this one, feel free to try it with your learners. And yes, this can work at any level. There's some algebraic thinking involved, but you don't have to do algebra to answer this. What you really have to do is be invested in being willing to problem solve and critically think. And as the teacher, I need to be invested in being willing to hear the questions, the notices, the wonderings, and then do what we said. Show them where to look, but not what to see. And a good way to do that is by asking questions to get them to look, but not what to see. So some of the questions that I would ask when I would get answers to this, because I've done this recently with teachers, a room full of math teachers, and they all immediately got the problem and said, oh, well, the answer is 13. because I did not say that it was a multiple solution problem. So everybody almost all boxed themselves in to just like one answer. Okay, so I'm like, okay, I have to show them where to look. So I asked the follow-up question. Are you sure that there's only one whole number amount, even though the word says amounts? What do you think it means by the fact that it says amounts? And then one teacher in the room goes, oh, that's right, it does say amounts. That means there's more than one, right? And then that set the whole room on fire and everybody went right back into it. So these are things that as a teacher, right? Like, what are your beliefs and values that you're trying to push? And that are your students getting it? That you care about their thinking and you're going to give them opportunities to problem solve and brainstorm and analyze and look for best solutions. So thank you for all the chats in the chat box. If you want to continue thinking about it, if you're wondering if your answer was right or wrong, I never really tell somebody if their answer is right or wrong because I care about their thinking, not their answers. But if you want to send me an email afterwards or you want to have a deeper conversation about it, coaching session would be the best place to do it. So we're going to move on to our reflection. Thank you all for participating in that. So those are our two instructional routines. Our two instructional routines are multiple solution problems and classifying statements. And as you can see, you can layer in the slow reveal, right? That's up to you. That's that scaffolding if you think it would be more helpful to give the students, the learners, a piece by piece by piece of the problem to help them really critically think a little bit more clearly. How can we really know the exact whole number? Well, you can, right? And that's a good question. How can you really know? Especially because they told you can't estimate. You can't. So this would be where we would have that whole classroom discussion. And then somebody eventually will start saying, well, you pour the water completely out of one bucket into another bucket. And that is how you're sure how much. That's actually how we get 5, right? If you fill 9 all the way up and then pour 9 into 4, what's left in 9 is 5. But then, that's when you start having the, well, what if you spill it? Right? That's why I said as a teacher, you can help guide them a little bit more back to the thinking around the context of the problem. All right, so let's reflect on critical thinking and problem solving. I want to bring you back to your practice and what you got out of today's session around critical thinking and problem solving. Can you type in the chat box what other aspects of your program, other than math, require learners to elicit and use problem solving and critical thinking skills? I love that verb there, elicit, not just to use, but to elicit as in like, I'm actually looking for me using problem solving, critical thinking, because I feel like math is the low hanging fruit. We all know math teachers teach problem solving, but what other aspects of your program, your ABE program, I see ESOL, where else? I mentioned earlier, workforce, I'm the workforce development and math specialist at where I work at. I can't talk about workforce and not talk about critical thinking and problem solving. Where else in your program? Tables, charts, graphs, social studies, science, reading and having discussions, cause and effect, parenting, that's a good one. Oh, there's a lot of problem solving in parenting. Writing a critical essay, excellent. I have one more question for you here. We're going to go back to the question we had earlier about your practice. Remember the question I asked was, what attitudes, beliefs, and values is your instructional practice actually reflecting? When you're teaching math, is it reflecting, I'm giving you opportunities to build problem solving and critical thinking and some of the ways that we've done here today in the last 30, 40 minutes? Or would you say it's more like, no, it happens, but then like, I'd say 45 to 55% of the rest of it is, I got to get them the steps because they need those steps because they got to pass this test. And that's really what it has to happen. Again, you don't have to answer that in the chat box, but I want you to think about this for yourself as a practitioner. Your instructional practice, what attitudes, beliefs, and values is it actually reflecting? And does your practice reflect that you believe your students can build critical thinking and problem solving skills? Or do you see a problem, you were looking for a problem in a book and you found a problem and you look at it and you think to yourself, my students can't do it with those numbers. Let me take those numbers down. My students can't do it with that, let me do this. And I'm not speaking against scaffolding and putting in supports at all by any means. I'm asking you to think, is the way that you're teaching genuinely reflecting that you believe your students can build and develop critical thinking and problem solving skills? So let's discuss this more and ways that you can ensure your teaching practice does reflect your beliefs and values and attitudes about skill building. And we will do that in the subsequent coaching sessions that Lauren mentioned earlier. And we will also look at what are some ways that you can actually try to implement these two instructional routines that we covered today, which are classifying statements and multiple solution problems. And we might even look at another multiple solution problem in one of those coaching sessions. It's one of my favorites. It has to do with iPhones. And those iPhones magically fell off the back of a ship and went missing. So if you want to know what happened to the iPhones and what you could do with those iPhones and how it relates to a multiple solution problem task, you should come to one of the coaching sessions. So on that note, I hope this was helpful and gave you some things to think about. I hope your brain is percolating a little bit, and what you might want to try or want to do or how you could use it. So can you take a moment to please scan the QR code? I do see I have a question here in the Q&A box, so I will address that after I say this one thing. Can you please take a moment to scan the QR code and fill out today's webinar survey, because your feedback does matter to us. And we do care very much about whether or not these are effective and helpful for you and what ways that we can continue to make them better. Someone did answer yes, Carrie, it is going to be recorded. Danielle will be sending out follow-up emails with the follow-up sheet that I mentioned that has the links in them with more information and the slides as well. Do I have any tips for implementing routines like this in a one-on-one tutoring situation? That is something that we tend to address in the coaching sessions because I know these are tutoring things. And I would say, yes, I would implement both of these, and I have in a one-on-one tutoring situation. I tutor quite frequently, and I've used both of these. In fact, the classifying statements is one of the ways that I will start a tutoring session, right? Like if I know we're covering, I don't know, if I know we're covering proportional reasoning and percentages that day, I might start off with a classifying statement that's going to get at what I need to know that that student knows about proportional reasoning and percentages that day. So there are lots of ways that you could use both of these routines in one-on-one setting. Yes, you'll have to take away that whole group aspect, but then that gives you an opportunity to bounce off with your student, and that's just going to have to make your questioning that much more targeted, aka the sentence we said earlier. Show them where to look, but not what to see. And the best way to do that is by the questions that you ask them to get their brain to start looking in that direction. All right, Danielle, take it away, please.
Okay. Lauren, did you want to do it?
Go ahead, Danielle.
Oh, sorry.
Okay. No worries. So we do have some upcoming webinars. Cynthia's next one in for the math track will be held on April 18th, and the link is in the slide, and I will also put a link into the chat if you'd like to go ahead and get a head start on that. And then our other upcoming tracks are HSE, high level ELL, basic literacy, and our workplace literacy tracks. So I will put those links in the chat now, and then the next slide. And again, the coaching sessions are already in the chat a couple of times, so this will also come in the resource recap as well, along with the membership link and the scholarship link. And that's all I have. Lauren, do you want to wrap it up?
Sure, thanks, Danielle. So as Danielle said, all those links, many of them are already in the chat. The ones that are not will be in those follow-up materials. You can't click on that link right in the presentation that you're seeing right now, but as soon as you get that link to the PDF of the slides, you can click any of those active links throughout the presentation. We do have a couple minutes left, so if there are any final questions for Cynthia, go ahead and put those in the Q&A. This was a really informative webinar, Cynthia. Thank you so much. We appreciate it. And It's such an important life skill, as you mentioned, to build in students.
No problem. I will hang around. Like you said, we have a couple minutes if anybody has any questions, any other questions. If not, I hope to see you all in the coaching sessions where we can dive deeper into implementation and practice.
Yes, I'm very curious about that iPhone activity. I might have to join the coaching session to learn about that one. That sounds like fun.
It fell off the back of the ship.
That
All
can
the teens
happen.
in the world, right? Want to hear about that.
Absolutely.
Right. I'm not seeing any, but still, I'll be here. Thank you,
Yeah.
everyone. I'm going to stop sharing the screen at least.
Thank you. So thank you all for joining us. We appreciate it. If you've got a question, throw it in that Q&A really quickly. We'll hang out for another minute. Otherwise, we will see you next time or at a different track webinar. Thank you, everyone. Thank you, Cynthia.
No problem.